So my goal with this talk, I don't want to teach everyone how to become a security researcher, and I couldn't even do that because I don't have a lot of time. But I would like to inspire at least some of you to get into this line of work because I believe that there's a shortage of people in our industry who are also doing security research. So in case you don't know me, I'm Gui Rambo. I'm an indie Mac and iOS developer, and these are my main products right now, but I also, like mentioned, do a bunch of open source stuff. So you know I'm a developer, but many of you here are also developers, but I'm also a security researcher. This is a huge topic, and there are specialists out there doing amazing work at very low levels of the technology. But I think developers like us have a unique perspective on things, and our knowledge of the higher level things can be a great tool to help us find some low-hanging fruit security issues that most full-time researchers are not paying attention to. And as you'll see later in this talk from the example I'll be presenting. So what is security research? Before I get into the specifics, I think it's worth explaining some concepts that will come up throughout my talk to make sure we're all on the same page. Some of you may already know them, but I'll try to go over them quickly. So security research is the practice of exploring software, operating systems, and hardware to identify security vulnerabilities that could be exploited by attackers. Notice how I said attackers and not hackers. And there's an important distinction here, and I think it's worth getting into. So what is a hacker? Most people, when they hear the word hacker, will think of the Hollywood movie stereotype of some guy, it's always a guy, in a black hoodie sitting in a dark room with lots of screens in front of them, frantically typing on the keyboard. But in reality, a hacker is anyone who explores and manipulates systems in ways not intended by the original developers. That work can be done for malicious purposes, of course, but not all hackers fall into that category. That's why the industry has coined the term white hat hacker. I personally prefer the term ethical hacker, which is the person who finds and reports security flaws with the goal of improving security for everyone. You might be wondering how ethical hackers get paid for the work, and a lot of the time is through a bug bounty. So a bug bounty is a program where companies offer financial rewards to security researchers who discover and responsibly report vulnerabilities in their software. Programs vary a lot from company to company, but in the case of Apple, bounties range from $5,000 up to $2 million. And I'll tell you more about the Apple bug bounty program and how to get involved later in the talk. How to get Tim Cook to give you money. You might be wondering, why would a company like Apple pay some external researcher for a bug when I'm sure they certainly have their own security team? And the truth is that everybody makes mistakes. And no matter how large or how good your security team is, there's always going to be vulnerabilities that slip through the cracks. There's also a really dark side to this. An extremely profitable market exists for selling security vulnerabilities to authoritarian governments or private entities that sell spyware, which can be used to target specific individuals like journalists or activists. And by offering a financial reward for responsibly reporting security issues, companies make it less likely that researchers will turn to that illegal market, which often pays large sums of money for certain types of vulnerabilities. I mentioned reporting security bugs responsibly a few times. That's what the industry calls responsible disclosure. What this means is that you're going to report an issue only to the company that develops the affected software without disclosing it publicly. You will then give that company time to develop and deploy a fix for the issue, after which you're then able to talk about it publicly. This is to prevent a 0-day from falling into the hands of criminals before the majority of the users of the affected products have had a chance to get the security update. And that brings us to the last term I'd like to explain, which is 0-day. A 0-day is a security vulnerability that is not known to the developer of the affected software, so it has no available fix. It's called a 0-day because attackers can exploit it before the company has had any time, or 0 days, to address the issue. 0 days are the most valuable exploits because if they get in the hands of bad actors, they can be exploited to target individuals who have no way of closing the vulnerability since the company has not released a patch for it. These are the types of issues that are usually reported and receive bug bounties. Now that we are on the same page with the terms of the trade, let me get us on the same page on why I think you should get involved and then on how you can get involved. So if you've ever debugged a tricky issue, found a creative workaround for an API limitation, you've already been thinking like a hacker. Security research is just shifting that mindset from making things work to figuring out how they might break. So you don't have to become a hacker because you already are one. Security research is not a mysterious skill set. It's just a shift in focus. Instead of finding ways to make the software work better, you look for ways it might break. And once you do that, you get a few benefits. First of all, you'll become a better developer by improving your debugging skills, understanding how things work under the hood, and making your software more secure. You also have an opportunity to make the systems more secure for everyone by responsibly disclosing vulnerabilities to Apple so that they can address them. And to top it off, you might even get paid a decent amount of money through the bug bounty. So I hope to have convinced at least some of you that this is an area worth exploring, even if it's just as a side project. Now let's see how you can get involved by exploring ways to get started. The first skill that will help you is reverse engineering, which is the process of taking apart software to learn how it works without access to the source code. In the context of Apple platforms, this usually involves decompiling Apple system binaries and frameworks to uncover potential vulnerabilities. Now, it might be daunting in the beginning when you decompile a piece of software and get face-to-face with just a wall of assembly code. If I'm going to be honest, I am not that good at reading assembly code, really, but the good thing is that most reverse engineering software has the ability to display pseudocode, which in the case of iOS or Mac apps will usually look a bit like Objective-C. So now let me give you a taste of what it's like to reverse engineer an Apple binary. I decided to show you an example where the goal is to find out what happens after my app calls an API from the SDK or where the API call ends up going to. Apple recently introduced API for apps to integrate writing tools into custom UIKit or AppKit views. So let's say I wanted to learn how this API works, or at least where it ends up going to. I'm going to be using AppKit as an example. My first stop was in the documentation, where I learned that the entry point for this API on Mac apps is NS Writing Tools Coordinator. It has this method called isWritingToolsAvailable that's used to check whether the feature is available on the user's device, and that's the method I want to dig into. Let's see how it works. Notice I'm viewing the Objective-C documentation. For APIs that are available in both Swift and Objective-C, it is better to look at the Objective-C version, as most APIs are still implemented in Objective-C, so the names that you'll be able to find in this assembly are usually going to be the Objective-C ones. So let's use the Hopper app in order to disassemble AppKit. The AppKit framework, just like all system frameworks and libraries, is a part of the DYLD shared cache, but Hopper luckily supports loading the shared cache and extracting a single binary from it. Once Hopper has finished processing AppKit, I can search the list of symbols for NS Writing Tools Coordinator, and as you can see, it first finds a bunch of symbols defined in a category on NS Text View. But scrolling down a bit further, I can find the isWritingToolsAvailable method I was looking for. Selecting the method reveals its assembly code. As I've mentioned, that can be difficult to read, but Hopper offers a pseudocode mode we can use to get a simplified view. Checking the pseudocode, I can see that it first calls this underscore writing tools UI library core function, then checks that it didn't return 0 or nil. It then calls this, let me take a breath here, get WT writing tools view controller class underscore block invoke function. Whenever you see a disassemble function with the block invoke suffix, that means it's an Objective-C block. So parsing the name of that block invoke function, we can clearly see the name of another Objective-C class, WT Writing Tools View Controller. I can already tell what's going on here from experience, but let's dig into that Writing Tools UI library core and that block invoke function so that I can explain what's happening. The Writing Tools UI library core function is calling SLDLOpen. Some of you may have already heard of the DLOpen function before. It's used to load a dynamic library at runtime without linking to it at build time. The SL prefix in this case comes from Apple's soft linking private framework, which is used by Apple to soft link certain system frameworks to other system frameworks, which can be done for a variety of reasons, but it's not relevant here. All right, so we know that Writing Tools UI library core uses DLOpen to load a dynamic library. Going back to isWritingToolsAvailable, we can see that the result is being assigned to R0, which is, if it's not nil, we'll continue on to calling that block invoke function. Looking into the, I'm not going to say it again, block invoke function, it calls into yet another library function, this time Writing Tools UI library without the core. It then calls obj-c getClass, which is an Objective-C runtime function that can be used to look up a class dynamically to get the WT Writing Tools View Controller class. Almost there. If it finds the class, it assigns it to an address, which usually means assigning the value to a global variable. Once that's done, it returns the class as the output of the function. Back to isWritingToolsAvailable, we can see that it eventually calls an Objective-C method called isAvailable on something. And given what we've seen so far, it seems pretty logical that this something is the WT Writing Tools View Controller class, and that this class is in a library named Writing Tools UI. If I once again load the DYLD shared cache into Hopper and search for Writing Tools UI, I can see a private framework with that name. Once loaded, I can confirm that this framework has a WT Writing Tools View Controller class that implements the isAvailable method. So given all we've seen so far, the answer to the original question of what is the isWritingToolsAvailable API doing is simple. It calls the isAvailable method on the WT Writing Tools View Controller class. That's it, all of this just to figure this out. But it seems like a lot of work to just learn that the public API is just a simple wrapper for another system private API. But that's because I explained it step by step here. In reality, once you get a bit of experience, you make such a conclusion just by looking at the disassembly or pseudocode. Of course, this just scratches the surface of what the API actually does behind the scenes, but it's all I have time to demonstrate here today. The next step would be to do the same process, but this time with the Writing Tools UI disassembly by digging into which functions that isAvailable method calls. was an example of what's called static analysis, where we take apart binary and look at it without actually running it. Another approach is dynamic analysis, where we actually hook into the process at runtime and inspect what it's doing. Now, doing that for system processes on iOS is effectively impossible without a jailbroken device or a security research device. But on the Mac, it's a lot easier if you disable some security features, which you can do in a virtual machine, using VirtualBuddy, maybe, if you don't want to risk messing up your own computer. However, we can inspect a great deal of what happens behind the scenes of an API call like that by just using LLDB when running our own app within Xcode, which is what you can see in the slide there. So you've already learned about some tools in the previous example, but I'd like to mention a few more. I won't have time to detail them, but you can ask about them later, and I have a link on my GitHub with all of the links for the talk. So the first two are the IPSW command line tool and Frida. And then there are the different disassemblers that can be used, Ghidra, Hopper, which we've seen, Binary Ninja, and IDA Pro. Just so you get some names and you can do some research later. I mentioned the security research device and how it's necessary for iOS research. That's because iOS is locked down so much that it's really difficult to perform dynamic analysis on production devices. That's why Apple introduced the security research device, which is a special iPhone that allows custom code to be installed so that you can hook into system processes and inspect what they're doing. It's been around for a few years, and I'm currently using iPhone 14 Pro and iPhone 16 security research devices that Apple sent me, which you can see here. And they do allow me to show pictures, so don't worry. Once you've gotten started and had a few CVEs credited to you by Apple, I would encourage you to apply. Now, one of my favorite things to do is to read blog posts written by security researchers who have responsibly disclosed an issue to Apple. They're usually very in-depth and technical, and learning about how someone else found a given security flaw has helped me think of new ways to approach my own research, and sometimes even inspired me to look into areas I hadn't looked before. The first step is to find an interesting CVE code. Every security flaw that's disclosed gets assigned a CVE number, which helps track and reference specific vulnerabilities across different security databases. And you can find the CVEs for Apple software in the security updates page on Apple support website. Once you've found the CVE, you'd like to learn more about, you can search for it in your favorite search engine and include keywords such as blog to make it easier to find. And in this case, I found the first result was a blog post from the security researcher written about the issue. Doing some self-promotion, there is my blog as well, Rambo.codes, where I don't write very often, but I do have a few posts in there detailing previous security vulnerabilities that I have reported to Apple. Speaking of which, I'll quickly tell you the story of one of them and use it as an opportunity to explain how you can report a vulnerability to Apple. So far, I've had a little over 10 CVEs credited to me, some of which involve more complicated techniques and subsystems, but I have at least one that was very simple to find, and I found it completely by accident. So this one, I was doing work with Ben Sherman from NS Screencast, and as we recorded the first video, we looked for ways to make it easier for people to set up code signing, which involves typing in your developer team ID. And I was trying to find ways to figure out developer team IDs the user had on their Mac. As some of you may know, it's possible to read and write the user defaults for any app on macOS using the defaults command. So I ran defaults read com.apple.dt.xcode, searched for my developer team ID, and found it. But I also found something that I didn't expect. My developer account email address was used as a key in the dictionary. It meant that Xcode was storing potentially sensitive user data, in this case, Apple ID email address, in an insecure way, which can be accessed by pretty much any app on the system. The next step was to actually write a basic app that would read user defaults from Xcode and display a list of the information collected, including the Apple ID email address. As far as data leaks go, this is a minor one, as it's just a developer ID email address, but it definitely falls into the device attack via user installed app category. Once I had a sample app ready, it was time to report the issue to Apple. Until not that long ago, this was done via email, but more recently, they have introduced a web portal where you can report vulnerabilities. Anyone with an Apple account can report vulnerabilities, and if you are eligible to a bug bounty, Apple will pay you through your banking information configured in App Store Connect. If you don't have that set up, they will help you set it up, and they will waive your developer account fee. So here's what the report for this Xcode bug looked like. This particular one was very short because it was a very simple issue to explain, but most reports are a lot longer than this. But I wanted to use it as a simple example to demonstrate how straightforward it can be to report an issue. And in case you're wondering, Apple paid me a bounty of $7,500 for this report. So here's what I usually include in reports. Some background on the affected process or API and what its intended use is, how I was able to exploit it, what the consequences are to users, and ideas on how the issue could be addressed. Besides the written report itself, I also like to include an Xcode project demonstrating the exploit, a pre-built binary for the app, and depending on the exploit, a video or screen recording. So I hope I've been able to inspire some of you to get into security research. A lot of great hackers start out as curious developers, just like you and me. The skills you already have can help you get started, and the impact you can make is real on your skills, on platform security, and maybe even your wallet. If you do get a bounty payment, though, please be sure to send me 30%. That's the deal. Thank you very much.